Hey everybody, thanks for coming to .NET Conf. We have just a short 30-minute time span to cover clean architecture with ASP.NET Core 6. My name is Steve Smith. You'll find me online as at our Dallas. I work for Nimble Pros. We help companies with training and implementation to move to the cloud and move to clean architecture a lot of the time and follow domain-driven design principles to build better applications. So one of the reasons why I really like clean architecture, and hey, we've got the slides showing now. That's awesome. Is that it's able to make it so that we can focus on the business logic and the problem we're trying to solve, and not get hung up on all the plumbing and infrastructure concerns that really make it difficult to build applications that we can test with automated testing that we can deploy with confidence because we have that automated testing and automated deployment pipelines. All right, so let's just talk about what is clean architecture. And very briefly, clean architecture formerly has gone by other names. These include things like onion architecture, which my friend Jeffrey Palermo came up with that name and some blog posts about, I think it's been like 10 years now. Hexagonal architecture or ports and adapters were also commonly used names even before that. But basically, it's a domain centric approach to organizing the dependencies in your application. All right, so any application that we're going to build, it can usually be broken down into different concerns. We've got some user interface concerns. We've got business logic. We've got somewhere we need to persist data, typically. We probably have other concerns as well, but those big three items are generally present in just about any business app you're going to build. And so clean architecture provides a way for us to organize those concerns in a way that lets us continue to maintain that application over the long haul. Now, there are two common approaches to this type of organization. The first one is what I call N tier or N layer, and it stacks those concerns like the user interface, the business layer, and the data access layer, like you can see here, where the data access layer is responsible, obviously, for talking to the database. The business layer talks to the data access layer and depends on it, and the UI layer, in turn, depends on the business layer. Sometimes the UI layer might do an end run around and talk to the data access layer directly. That's usually frowned upon. But at the end of the day, this is what the dependencies look like between all these. And what that means is that your whole application generally is going to be dependent on that database. Now, what clean architecture does is it kind of flips this around a little bit and it says, we're going to have the domain be the thing that everything else depends on. We're going to have the user interface depend on that domain model. We're going to have infrastructure implement abstractions or interfaces that are defined in that domain model. And they're going to use types that are defined in the domain model, not somewhere else. And yes, the infrastructure layer is going to be responsible for persistence. It's going to be what's talking to that database. Now, it turns out that if you build these applications in using both of these structures, frequently you're going to have some health problems with that app when it comes to maintainability once it gets to a certain size. I often go to clients and they're coming to us because they want us to help them, fix their application or help migrate it somewhere. But it's a big application. They've been building it for 10 years, and it's organized in this N layer approach. And I asked them, well, what kind of pain are you feeling? And wait, before you tell me, do you have problems like there's lots of stored procedures, there's lots of logic that's in the database, there's things that you're afraid to touch because you don't know what else is depending on it, you've got a database that's shared by multiple applications that are all using similar architecture to this, and so you can't even rename a table or a column without fear that it's going to break some other app. And yeah, they're usually nodding their head like, yes, yes, those are the things, right? And so clean architecture, if you apply it, the nice thing is that you're not coupled to that low level database stuff, right? Your application is free from it. You can swap it out, right? It's a pluggable architecture. And so if you're using SQL Server right now, but in certain environments, it would be nice if you could use something else, like maybe in your test environment, you want to use SQLite because maybe it's easier to blow it away and reset it or something like that. Maybe in production, you're thinking about using Cosmos DB, right? You can plug in those different implementations to this architecture without having to change the UI or the business layer. All right, so this end tier approach has been around for a while, right? This slide is actually from the MSDN website that Microsoft has, their Microsoft Developer Network, around 2001. So that's like 20 years ago, literally. And you can see there's different ways that you could take something that had no separation of layers, which was pretty common back then, and break it up into these different layers based on responsibility. But no matter how many layers you broke it up into, with this architecture, the dependency always ended up being on the database. And what we'd really like is something that's more like this diagram, which is also from the early 2000s. And you could probably get a sense for where the names ports and adapters or hexagonal architecture come from, just by looking at this diagram. Now, if you look at the center here where you have that green hexagon, that's your domain layer. That's going to be your business logic and all the things that belong there that have to do with business rules and the entities that you're modeling. You may have an application layer that sits on top of that, but provides a set of services that your user interface is going to talk through. Sometimes you benefit from that. Sometimes you may not need it. But the little purple circles there are important. Those are called ports in this diagram. What they really are is abstractions, typically interfaces in your code, and they represent the things that you're going to plug into from outside of the core project in your application. So on the left, you've got different ways that you could plug into the application layer with different UI implementations. And on the right, you have different ways that you might plug in different persistence mechanisms or different ways to talk to other systems through APIs or something of that nature. And so the idea here is that you have a plug and play model for your architecture that lets you swap out the pieces and how they talk to that core application model. All right, so this is another slightly more updated diagram that shows what we're going to talk about today. And in this one, we're going to have that center domain layer. We're going to call that the core project because it's at the core of the whole system. And that's where your domain model and abstractions are going to live. Outside of that, you're going to have your web project because this is a .NET 6, ASP.NET Core 6 application at the end of the day. We're going to have a separate infrastructure project. That's the only place in the whole system that's going to know anything about our data access. So there's not going to be any DB context or EF core or Dapper or other type of code in the other projects. It'll all be in that infrastructure project. And then we'll have a couple of different test projects that'll interact with this whole system and talk to different other projects. All right. Now, the nice thing about clean architecture is it's pretty simple to follow these basic rules. First, you want to make sure that all of the business logic is in the core project. So you don't want to have sort of leaky abstractions where you have business logic that is in store procedures or it's in JavaScript inside your web application. Ideally, now you might duplicate some rules just to increase user responsiveness or something like that. So if you're going to perform validation in your domain model, but you also want to do some validation on the web form, then that's perfectly okay. But you don't want to have any of your business logic only exist in the UI and not be inside of your domain model. Then you want to make sure that all of your dependencies flow toward the core project. It's very important that we keep the core project free of dependencies itself. And the way that you do that is you make everything else depend on it. One of the nice things that Visual Studio and the .NET project system in general does for us is it won't allow us to have cycles inside of our project references. So if I say that the infrastructure project depends on the core project, I can't then go and say that the core project should now depend on the infrastructure project. Visual Studio won't let you do it. And so that it is helpful for our solution to enforce these rules that your domain model should not depend on infrastructure because we're setting it up with these separate projects, right? Those are going to help us fall into the pit of success and make the right thing easy and the wrong thing hard. Then the third rule is sort of a consequence of the second rule, which is that we need to define our interfaces or our abstractions inside the innermost projects, usually the core, and then outer projects can implement those interfaces. So you don't want to have your interface, for example, data access, live inside the infrastructure project, because that's going to force things that want to use that abstraction, like the web project, to then have a direct reference to infrastructure. We want to have the web project reference the core primarily and minimize any interaction it has with the infrastructure project. Okay, so what belongs inside that core project? And in just a second, we're going to look at some code, so you'll be able to see this a little more concretely. But sort of abstractly in general, these are the kinds of things you're going to find inside that core project. The first one is going to be interfaces. Most of the abstractions, most of the interfaces that we're going to use in our application, whether they're describing how to do persistence or whether they're describing how to send an email, or even business logic things that are certain domain services, are going to have interfaces that represent them, and those are going to live inside the core project. Then we have to have some way to model the actual things in our system that have state and have some persistence. And those are typically going to be aggregates and entities, as well as value objects. Now, entities you're probably all familiar with. Those are basically the things in your system that have an ID and that you store in a database with that ID, and then you fetch them by looking them up by that ID. The identity is where the entity name comes from. And so things that have an identity and live over time are entities. Aggregates are just a domain driven design pattern for grouping entities together to give you another encapsulation boundary and make it easier to do persistence with groups of related things. Think about something like an order with all of the order items. You could construct that as an aggregate, and then when you persist it, you would store the whole order and then fetch the whole order. You wouldn't typically want to work with just an order item all by itself. Value objects are things that don't have an identity and that you can compare just by looking at their properties. And so, a very common value object that you've probably all worked with is the date time in .NET. One of the really nice things about value objects is if they require validation, you put that validation into the constructor of the value object, and then you don't have to check it anywhere else in your code. And so, frequently, a lot of apps I looked at, they're not using value objects as much as they should be. And so, there's lots of places where validation or invalid out of range values can exist inside of entities, and so you're having to do checks a lot of the time to make sure things like the start date precedes the end date and things like that. If you created something like in that example a date time range type, then you could verify in the constructor of the date time range that the end date follows the start date, and now you can use that anywhere and be confident that it works. I'll bet you've probably never had to do a check on a date time to verify that the day didn't exceed 31, right? Because it won't let you make one like that, right? That's the same benefit you get in your domain when you start to apply value objects. All right, you might also have domain services. This is where logic lives that has to do with multiple entities or value objects and how they work with each other. You want to try and put as much behavior into your entities, aggregates, and value objects as you can, but sometimes it doesn't belong in one of those. And so you have domain services for that type of thing. I really like custom domain exceptions instead of relying on a low level exception like a null reference exception that some developer has to go and debug the system and figure out what it is. Why not throw a domain exception that says something like customer not found exception or order doesn't exist exception or something like that, where it's much more clear what is null, what is the thing that's missing, without you having to debug to see what it is. Domain events and domain event handlers would also live in the core typically. You could have handlers in other places as well, but the events themselves should usually be defined inside of core. Domain events are another DDD pattern. I'm a big fan. Julie Lerman and I have a course on Pluralsight where we talk about these. I don't have time to cover them in this very quick clean architecture talk, but they're an awesome pattern you should check out. And so are specifications. Specifications are a way to take query logic and take it out of your repositories, take it out of that link that you've got cluttering up all your controllers, and put it into your domain model. I have a NuGet package called ardalis.specification that you can just grab and use and put your link into those specifications in your domain model. Give them good names that say what they are, and then you can reuse those. And you can also test them without having a database. You can actually just create a list of items, apply a specification to it, and verify that you got back the subset that you were expecting using that specification. Any kind of validators you need for your domain, using something like Fluent Validation would live here. Enums or smart enums that are like classes that sort of act like enums would also live in core, along with any custom guard clauses you might have. Guard clauses are simple validators you do to make sure your system is in a consistent state. And you could create your own custom ones that you reuse that apply to your domain model. I have another NuGet package called ardalis.guard clauses that you could use as a starting point for that if you want. All right, so with all that, let's look at an actual core project. And while we're doing that, let's show how to get started using the clean architecture template. So first, let's go to a browser window here. And this browser window is on GitHub. It's github.com/clean architecture. Get my mouse up there so I can zoom in for you. There we go. And so this has all the stuff I'm going to show you. So you can just jump out to that GitHub repo. You can look at it, browse it, clone it, download it. Then on NuGet, we have a Ardalis Clean Architecture template. So this is the project template that you can use to create this. You can see I was just updating this a little bit within the last hour or so. So what you need to do is this line right here that'll let you install this template. So the very first thing we're going to do is that. So we'll just copy that, jump to PowerShell here, and make this a little bigger, and then we'll just run that. And I've already installed it, so it's going to say it's already installed. Okay, now that you have this installed, the other thing you can do is say .NET new list. This will show you all your things that are installed. And you'll see the ASP.NET Clean Architecture one is here. This is just in alphabetical order. So clean dash arch or arc is what you want to use. So we're going to use that now. We're going to create a new template. We'll say .NET new clean. That's not how you type. Clean arc, and then we'll call this nimble pros .NET conf. And assuming I don't have that already, so assuming I don't have that already in this folder, which I don't think I do, it should create it. All right, so there it is. So now we can cd into that one, and then we can just do the solution file. That'll open up Visual Studio. And now we'll see what Visual Studio has with the clean architecture template. Now, the reason why I have this template is because normally in Visual Studio, when you're using templates, it only gives you project templates. And it's really tedious to create the structure that you want, doing it all by hand with project templates. You have to, create a class library and create another class library and create a web project and set this reference and set that reference. And it's just a bunch of crud that you don't have to do if you've got a template. And so the template basically gives you these 7 projects. There's core, infrastructure, and web, along with something called shared kernel that we'll talk about in a minute. And then there's 3 different types of test projects, and those are broken out based on whether they're testing the whole web application, which is the functional test, whether they're testing some aspect of infrastructure, which is most of the integration test, or the unit tests, which are just testing things that don't have any dependencies on infrastructure at all. So let's look at the .NET Core project. And in here, you'll see we have interfaces. We have broken things down into an aggregate. And in here, there's some handlers and some specifications. All right, so if we zoom in on this, let's take a look at it. What you're going to see is that there's a couple of interfaces here that describe certain types of services that we might want to implement, like the search service and the email sender. There's a project aggregate. Now, how you organize your folders is totally up to you. But recently, I'm following sort of like a feature folder approach inside of my core project where I group things based on how they're likely to change, right? When I need to make a new feature or add some new behavior, I'm usually doing it limited to a particular aggregate and not, just going into a folder called entities that might have 50 different classes in it. And so by grouping this into aggregates, most systems are only going to have, up to a dozen or so aggregates typically, and fewer if you can break it down and follow a more microservice approach. And so there aren't going to be too many of those folders, but inside of them, I'm going to have all the events that relate to that aggregate, all the handlers for those events, all the specifications for how to fetch and persist those will all be in that same place. So by organizing things like this inside this project aggregate, I'm able to make sure that all the things related to it are right in this location. Okay. Um, the entities themselves are going to be this project. And this is, again, this is a solution template. So you're going to throw all this away. This is just there to kind of show you how things might be organized and give you like just a starter. It's not a sample app. It's just a template for you to start as a solution. So in here, we've got a project. It's a base entity. It's an aggregate root. That interface is used to enforce the persistence rule that says that we only want to fetch and store aggregates as a whole, not individual entities. And so if we look at, it has a collection of to-do items inside this project that's a child of this. If we look at the to-do item type, you'll see it's also an entity, but it is not an aggregate root. All right, so it's not going to be something we can persist on its own. All right, so that's about as much time as we can spend on that. Let's get back to what goes in the infrastructure project. And the infrastructure project is just all the things that talk to stuff that's out of your process. So it's going to have data access in the form of repository implementations, DB contexts, cached repositories if you're using that. It might have API clients, how to talk to the file system, whether you're talking to an actual file system on your local machine or talking to like Azure Blob Storage using some kind of storage accessor. Any type of email or SMS stuff is going to go in there. Access to the system clock might go in there. You might have other services and even other interfaces that live in infrastructure, but these would be only those interfaces that don't use your domain model for their parameters and return types. So for instance, if you're using some SDK and it's returning some Azure type, you don't want to put that in core because now you're going to have a dependency on Azure in your core project. So you would put that interface or any interface that uses those Azure specific types inside of infrastructure and then put any of those services in there as well. But you would typically not call them from outside of infrastructure. All right, so let's jump back and look at what goes in there. So we'll close this down and open up just infrastructure. And we're going to see there's not a whole lot there. we look at this, you see that we've got a data folder, and in there, there's the app.db context. There's our EF repository, and then all of our configuration of our entities is in there as well. Then there's just the email sender is pretty much the only other thing there. Now, these infrastructure modules, those are just used for the dependency injection. So I can keep my dependency wire up local to the project and minimize how much reference to it I need to have inside the web project where it's going to do the composition root of the system and wire up all those services. All right. So moving quickly, let's talk about what goes in the web project next. And the web project has anything that has to do with ASP.NET Core. So it's going to have your API endpoints or Razor pages, depending on if you're doing APIs or you're doing something that uses forms and server-side pages. Alternately, you can use controllers and views, but I think API endpoints and Razor pages are a better abstraction for both of those. Any DTOs that go along with those things, whether they're view models or API models or whatever you want to call them, those would live here as well, along with any kind of filters, model binders, model validators, tag helpers, etc. This is where your composition root will live. So this is where you're going to do configuration of services to say this interface is served by this actual implementation class. That's called your composition root, wherever that happens in your app. And that's going to be inside of the web project because that's the entry point for our app. That's where we actually start the whole application. In .NET 5 and earlier, that would be in startup.cs. In .NET 6, we've got new templates that have the minimal APIs inside program.cs. So you might just do that there instead of in a separate startup class. You might have other services and other interfaces there as well. Same rules apply as in infrastructure. These are going to be services that have parameters or return types that are made up of these types of things that you see inside the web project. So if it's working with view models or API models, if it's dealing with controllers or views or any of that, those services should live here because that's where those types are. All right, so let's look at a web project real quick. So we jump back here, close up the infrastructure, open up the web, and you'll see that inside of web for this template, I'm basically giving you all the different options that you want to use. So if you want to do API controllers, that's right here. If you want to use controllers and views, that's here and here. If you want to use API endpoints, that's here. And if you want to use Razor pages, that's here. If you only want to use one of those, just delete the other folders that you don't care about. All right. Everything else in here is standard ASP.NET Core stuff. And so if we look at one of these, let's go look at an API endpoint. We have all the project endpoints right here. They're broken out by the actual endpoint. And for each one, you can expand it and see right with it, this is the request that gets sent. This is the response that comes back. And here is the endpoint itself. It has just the code needed for that endpoint. So instead of having a whole big controller with 5,000 lines and a dozen different actions, each endpoint just has one class and its DTOs are attached to it right here. So that's a separate thing. You can go download the API endpoints NuGet package if you want. Otherwise, everything in here is just standard ASP.NET Core stuff. All right, so then what about sharing code between applications? Well, for that, DDD uses this shared kernel term. And what it does is it holds common types that you want to share between your different apps. And they're typically referenced using your core projects and ideally distributed using NuGet packages. Okay. So what goes in here? Well, this would be all your base types for different abstractions. I'm going to just show you all these, and then you can pause if you want when you're watching this recording. So base entities, base value objects, things like that. Common interfaces. If you've got the same type of authentication you're using everywhere, you might have certain interfaces that you want to keep here or user types that you want to keep here. Same thing for guard clauses, same thing for common libraries you want to apply. All that stuff could live in here. However, make sure you don't put any infrastructure dependencies in shared kernel because all your different core projects in all your different solutions are going to depend on this. And again, we really want to keep that core project, your business logic, from having any dependencies on shared kernel. All right, so let's show shared kernel project, and then we will do a quick application demo. So I'll throw this resources slide up here. I want to briefly mention the eShop on Web sample. This is a full-fledged actual sample application. It's a reference app from Microsoft. So you see it's a .NET architecture under GitHub. I help maintain that repository. There's an associated book that goes with it, which is that other link there, the Architecting Modern Web Apps with ASP.NET Core and Azure. Download that and read it if you want. It covers a lot of these concepts as well and talks about the eShop on Web sample and how it's put together. All right, so with that, let's come in here and let's actually run this application. Well, let's look at the shared kernel briefly. So like I said, it has a bunch of base things in here. So you see there's the repository stuff is all in here, base domain event, base entity, etc., and a value object base class. Those are all what's inside of shared kernel. All right, so if we run this and give it a sec to start up, by default, it's going to kind of give you some documentation here on this first page. It says how to use the template, how to find help, et cetera, et cetera. In here, there it has all the Swagger stuff set up here. So if you want to look at the project endpoints, they're there. If you want to look at the controller, the API controller, it's here. Kind of does the same thing. If we want to get a particular project, there's some seed data that runs in here. So if you look up project ID 1, you'll see here's project ID 1. It has 3 items in it. Currently, none of them are done. They're all false. All right, so then we can close this down and say, well, let's go actually complete one of these. So we'll come in here, we'll say, I'm going to try and complete project ID 1, item ID 1, execute. And you can do all this testing right inside of Swagger. And so that is going to actually blow up because it's trying to send an email. But you can turn on a localhost mail server, but it sends the email after it does the persistence. So I know it already did actually set the thing that as it was supposed to. So if we come in here and we execute this one again, we'll see that now this one is done as true. And so if you want to pull this down and play with it, in addition to showing you how clean architecture works, it also has domain events wired up. It has specifications wired up. If I show you the repository implementation in here, the thing that may shock you is the fact that it doesn't need to have a whole ton of different things in it to say, get this project by that and get that, project with items and give me, this custom query. The reason why it doesn't have any of that custom query logic is not just because it's a tiny template, but also because we're able to use these specifications to perform those types of queries. And so I can take all that query logic, and instead of having custom methods in my repository, I can just have a different specification for each one. And when I need to perform a search, I can do that, inside of like this custom search service, where what you do is you just create the specification and then you call the repository and you say get by specification, and it will apply that query from the specification to your data. And you don't have to put that inside of custom methods. All right, so I think we're just about out of time. There might be a few questions. I will throw the resources slide back up for a second, and then the thank you slide, and then come back to Brady and see what you guys have in terms of questions.
Sounds good. We do have a few. Let me pull this screen up here. The first question is more of a comment. We had a nice compliment on your talk. The clean architecture presentation might be one of the best things .NET Conf so far. So
Nice.
Thank you for awesome talk, Steve. Billy asked a question here. Are the clean architecture available in .NET 5?
Yes, if you go to that GitHub repo, it has different versions going all the way back to, I think, .NET Core 2.1.
Okay.
They're just tagged commits, so you can just click on a link there. It'll take you to the right tag.
Okay, and any other question? We had Doug asked it and then asked it a second time here. I think what he was asking is C# classes and structs right here.
Yep. So you can use records for value objects. There's some downsides to them. Value objects should be immutable, and records can be. They're strictly immutable as they are, but you can make a copy of them using the with keyword that can bypass some of your validation if you have that inside your constructor. And I don't like that, so I prefer to use a base class and actually use classes for the value objects. But records are continuing to evolve, and I think we'll be able to get the protection that we want for value objects to be able to make sure that not only are they immutable, but also there's no way to construct one that bypasses the constructor and the rules that are in it in hopefully a future version of C#.
Got it. And I think I saw one more, this one right here, from David around .NET Conf, probably more minimal API, but I know you're into that too, Steve, so I thought this might be
the minimal APIs are great for starting up applications and not having to write nearly as much code to get started and start showing something that works. Once you get beyond a certain number of lines of code, you want to start breaking that up into methods, functions, right? Kind of organize it. And eventually you might move towards something that looks a lot like we had in previous versions of .NET, where, maybe you don't have a startup class, but you might have a separate method for configuring services and a separate method for adding middleware. It's totally up to you how you want to organize that. So yeah, you can use minimal APIs until you think that they're longer than you like, and then you can break them up.
Cool.
Awesome.
That's awesome. Well, I'm going to go ahead and add Jerome to the screen. And Steve, thank you so much as always. It's been great
Thanks.
to hear
See
from
ya.
you. Take care of yourself.